In an earlier tutorial, we described simple programs that use only primitive instructions. That description is shown on the screen. In that description, the first and last two lines are always the same. In between, we have a sequence of primitive instructions. These instructions are separated by semicolons. This type of description is fine for people, but machines require a more precise description. When these programs are processed by the computer uses a syntax diagram. Understanding these diagrams is the key to understanding error messages. Let's examine the syntax diagram for our simple program. In order to do this, we need to break the program into a sequence of tokens. Let's take a minute to talk about tokens. In any language, a token is a string of characters. This string can be treated as a single atomic unit in the language. Simply put, you can think of a token as a word, number or punctuation mark. In other words, we start at the beginning of the diagram. We process tokens one at a time. Each token acts as key to the next stage of the diagram. If it is unable to unlock that stage, an error message is generated. Let's get our program tokens. Beginning of program, match. Beginning of execution, match. Move. Move is a primitive instruction. Semicolon, match. Turn left. Turn left is a primitive instruction. Semicolon, match. Move. Move is a primitive instruction. Semicolon, match. Move. Move is a primitive instruction. Semicolon, match. Turn off. Turn off is a primitive instruction. End of execution, match. End of program, match. Success. Our last token unlocked the finish stage. When an error occurs, the simulator identifies the token that caused the error. It is important that first, we identify the last token that was processed correctly. This allows us to properly interpret the message. Again, let's illustrate with examples. In the first example, the turn token is highlighted. However, the last token processed correctly is semicolon. When we examine the syntax diagram, we see that an instruction is expected to follow the semicolon. The turn token is not an instruction, hence the error. In the next example, the move token is highlighted. However, the last token processed correctly is turn left. When we examine the syntax diagram, we see two choices following instruction. The first choice is end of execution. The second choice is semicolon. The move token is neither, hence the error. In the final example, the end of execution token is highlighted. However, the last token processed correctly is semicolon. When we examine the syntax diagram, we see that an instruction is expected to follow the semicolon. The end of execution token is not an instruction, hence the error. To summarize, For interpreting an error message, do not focus on the token being highlighted. Focus on the last token processed correctly and its place in the syntax diagram. Happy programming!